This video is on Unit 2, Chapter 6, Quadratics Extras, Lesson number 2, Quadratics Projectile Motion. So in this video, we are going to focus on the more application type questions where quadratics and parabolas are concerned. And before I get into the examples, I'm going to add a little something to our notes. So I don't know if you want to add this in the margins or on a sheet of notebook paper, but this is all kind of very important information. So with projectiles, a projectile occurs when you throw an object. So throw a football, hit a tennis ball, whatever. That's going to create the path of a parabola, and we refer to this as projectile motion. Projectiles are typically in quadrant 1 only. There are some instances where a person is jumping into water, so you might involve quadrant 4 of the coordinate plane because you're going to be going below the surface of the water. In all of these examples, all of these problems, the x-axis is going to be our time, which is our independent variable. The y-axis is going to be the height above ground, which is our dependent variable. So I've got this picture, and this is just a very basic example. Quadrant 1, your x-axis is the ground, or might be water level. The y-axis is the height. And I've got a parabola drawn, and it's some very important parts here. So the zeros, or the roots, are where that parabola is hitting the ground. So if I am kicking a football off of the ground, and it goes up into the air and comes back down to the ground, that would be an example. Sometimes, in some of these examples, somebody might be throwing a ball from a certain height. So they're on a platform or whatever, and they're kicking an object up, or they're throwing an object up and it's coming back down. So in quadrant 1, it's not going to be starting at the origin, because wherever they are, however high up they are, is where that object is starting. But the other key features here are the vertex. So the turning point at the top of the parabola is called the vertex, and that has an ordered pair, x, y. It's the maximum. We also call it the maximum. That should be a familiar vocabulary word there. And again, your x, y, because we're talking about projectile motion, the x is your time, the y is your height. So now what I want to do is I want to go and I want to look at some of these examples here. Let's look at example number 1. A soccer ball is kicked from the ground with an initial velocity of 90 feet per second. The equation h of t is equal to negative 16t squared plus 90t gives the height h of the ball after t seconds. Question A says, how many seconds will it take for the ball to reach its maximum height? So there's a couple of different ways we could do this. We could do this by hand. The maximum height is the vertex of the parabola. So if we could find the vertex, we could find how many seconds. The other way we can do this is using the graphing calculator. So I'm going to show you both pretty quick. So the first, we got our equation, h of t, which is just another way of writing y equals negative 16. I'm going to say x squared plus 90x. They use a t for time. So to find the vertex, we first have to find the axis of symmetry. So x equals negative b divided by 2a. That's a formula from the past to find the axis of symmetry. X equals negative b over 2a. So b in this equation is 90, so it's going to make that negative 90 divided by 2 times negative 16. So put that in your calculator. You're going to get negative 90. Well, let me just put that in the calculator. Negative 90 over over 2 times negative 16. Now this is going to give me a fraction. I want this in decimal form. So I'm going to hit math. I'm going to change this to a decimal. Number 2, enter. So about 2.8125 seconds. So remember X or T is our time. So this is going to give me 2.81 seconds. So how many seconds will it take for the ball to reach its maximum height? There it is, 2.81 seconds. Now it says, what is the maximum height? So by hand, I'm going to plug in the X to get the Y, or the T, the time. So we would take the negative 16, 2.81 squared, plus 90 times 2.81. And just put it in the calculator. Plus 90 times that 2.81. And we get about 126.56. And this is height. So height here is going to be in feet. So about 126.56 feet above the ground. And then it says give the domain. We're gonna skip that for right now. We'll talk about that in class. So those are the answers to question number 1. If I were going to do this in the calculator, I would first go to y equal, and I would put that negative 16. We have to use x squared in the calculator, plus 90x. And I'm going to zoom 6. I'm going to graph this. So here's your parabola. I'm going to zoom out just a little bit. And I still can't see the top. So the top of that parabola is the vertex, and I still can't see it. But if I want to know its maximum height, that point at the top, that turning point at the top is what I'm looking for. Second trace, that menu here is going to allow you to find the maximum point. So I'm going to select number 4. And then you'll notice at the bottom of the screen it says left bound. So we want to make sure that the cursor is on the left side of that top point. Well, if my top point's way up here somewhere off the screen, my cursor's on the left. I'm going to hit enter. And now it says right bound. What I need to do now is move the cursor to the right side of the parabola, which I've done. Hit enter one more time. And there's your maximum height. So 2.81 seconds, it is 126.56 feet in the air. So the calculator, by finding the maximum value, gives you that time and that height pretty quick. So let's look at question number 2. An apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation for this apple's height, h, at time t seconds after launch is h of t is equal to negative 16t squared plus 64t plus 80. What is the height of the apple after 3 seconds? So what that means, what is the height of the apple after 3 seconds? That means t is equal to 3. So this one's very quick, very simple, very easy. I really don't need the y equal feature on the calculator. I can just plug this in. Now, you totally could. I can show you a quick little shortcut here on the calculator. Let me figure this first. So I would have negative 16 times the 3 squared plus 64 times that 3 plus 80. And we're going to get about 128 feet. Now watch this. If I put that equation in y equal, go to y equal, negative 16x squared plus 64x plus 80. I'm looking for where, I forgot the x. I'm looking for where x is equal to 3. So if I go to the table, I don't even need to look at the graph, go to the table where x is 3, I got 128. So the table of ordered pairs there can help you. All right, let's move on to question number 3. A toy rocket is launched vertically upward from a 12-foot platform with an initial velocity of 128 feet per second. Its height h at time t seconds after launch is given by the equation h of t is equal to negative 16t squared plus 128t plus 12. How long will it take the rocket to reach the ground? So it's asking you, after it launches, how long is it going to take to reach the ground? Well, that would be a root or a 0. Let me back up to this picture that I had over here. So it's asking me the value of when it comes back and reaches the ground. Well, those are the roots of the zeros. So basically, what it's asking us to do here is to solve the quadratic. Find the value of x is what that's asking. We have to solve this quadratic, which means quadratic formula. We're going to use quadratic formula. A is negative 16, B is 128, C is equal to 12. So into the quadratic formula, x equals opposite b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So I'm going to find my discriminant. 128 squared minus 4 times negative 16 times 12. And we get a discriminant of 17,152. Over 2 times negative 16 would be negative 32. So in this lesson, decimals are actually going to be our friends. You are allowed to use decimals here. So I'm going to go through and I'm going to find both of these answers using my calculator. So I'm going to take that negative 128 plus the square root of 17,152 over negative 32. And I'm going to get negative 0.093. And then I'm going to repeat that process, but I'm going to change that plus to a minus. Or you could just retype it. Just use the minus. I get 8.09 seconds, or 8.09. So let's go back to the question. How long will it take the rocket to reach the ground? So the negative 0.093 doesn't make any sense because I'm measuring time. It's going to be the 8.09 seconds. There is a way to do this in the calculator. For those of you that are interested, if you plug the equation into the calculator, negative 16x squared plus the 128x, and I forgot the x again on my square, plus 12, I'm going to hit graph. So I'm interested in when it comes back down to the ground. So that point right there, which is a 0. Second trace is that same menu that I keep going back to. And we're looking for number 2, which is a 0. And here's the hard part. I need my cursor to be on the left side of that 0. So what I'm going to do is I'm going to try to get my cursor as close to that point as possible. And I can't. So this is actually going to be called left bound because it's above that point. And then arrow to the right again. There's your right bound. And there's the 8.09 seconds. Moving on to question number 4. Number 4 says a penny is dropped off the Empire State Building, which is 1,250 feet tall. if the penny's pathway can be modeled by the equation h of t is equal to negative 16t squared plus 1,250, how long will it take the penny to strike a 6 foot tall person? So the 6 foot tall person is the h. That's where h is equal to 6. So that's your h of t. So really and truly, substituting this in, the 6 goes in for the h of t, and then you got your negative 16t squared plus 1,250. And we would need to solve that quadratic. Notice here that there is not a bx. So I'm going to use my square root property to solve this. I'm going to subtract the 1,250. So 6 minus 1,250 is going to be negative 1,244 equals negative 16t squared. So then I'm going to divide both of those sides by negative 16. So let's see. Negative 1,244 divided by the negative 16. And we get 77.75. So t squared equals 77.75. And then I need to square root that. So square root that answer. And I get about 8.82 seconds. So it's all about knowing what these pieces are and what to substitute in and how to find those answers. It's a lot of thinking and problem solving. Let's look at, let's jump to number 7. Let's look at number 7. Eva is jumping on a trampoline. Her height h at time t can be modeled by the equation h of t is equal to negative 16t squared plus 20t plus 6. Would Eva reach a height of 14 feet? So it's asking here, how high can she get? How much her maximum height? What would her maximum height be? Well, remember, maximum occurs at that vertex. And we can find the vertex by finding the axis of symmetry. So find your x equals opposite b divided by 2a. That's going to be negative 20 divided by 2 times negative 16. So I've got negative 20 over negative 32. So that's going to be positive. 20 divided by 32 gives me 0.625. So that's how many seconds it's going to take her to reach her maximum height. To find her maximum height, you're going to take that and plug it back in to the equation. So h of the 0.625 is basically what we're finding. Negative 16 times 0.625 squared plus 20 times that 0.625 plus the 6. So I'm going to plug that in. Negative 16 times the 0.625 squared plus 20 times that 0.625 plus 6. So she's going to reach a maximum height of 12.25 feet. So is she going to reach 14 feet? No, she is not. Again, you could have plugged that equation into the y equal, graphed it, found the maximum height, and then and answered that question from there. Let's look at question number 8. A diver is standing on a platform 25 feet above the pool. He jumps from the platform at an initial velocity of 10 feet per second. Use the formula h of t is equal to negative 16t squared plus vt plus s, where h is his height above the water and t time t seconds, v, is the starting upward velocity, and s is the starting point to write an equation to model the dive. So the v represents the initial velocity. All of those words to say v equals initial velocity, and then s represents like his starting height above water or above ground or above whatever. So the h of t is going to equal the negative 16t squared. That's not going to change. Plus his initial velocity is 10 feet per second. So this is going to be 10t plus he's 25 feet above the pool. So there's our equation. And it says find the diver's height after 2 seconds. Remember that seconds is your x or your t. T equals 2. So I'm going to plug that in. So I've got negative 16 times 2 squared plus 10 times 2 plus 25. And we get negative 19. What does that mean? What would that mean? So if it's a negative 19, this is what I was referring to before. Normally, when we talk about projectile motion, we think quadrant one. Well, this is a person diving into water. So he's gone below the surface of the water by 19 feet. So sometimes you have to look at the problem to make sure that your answers that you're getting are actually making sense. And this one does because he's diving into water. So those are the examples in your notes for chapter 6, lesson number 2 on projectile motion.